All right, guys, here we are. This is 3.1 now, and there's a bunch of questions, 70 questions. So this time we're going to do the first question, and then we'll start doing multiples of 10, just for some random practice unless I get some specific questions. Okay, question one. What's the difference between an outcome and an event? The outcome is usually just one thing, and event is like a collection of outcomes. So outcome is over from one single event is well, no, event is not all possible outcomes, it's a collection of them. One or more. Yeah, that looks right. Okay, number 10. Now, first one's just a vocabulary question. Number 10, depending on whether the statement is true or false, when an event is almost certain to happen, its complement will be an unusual event. That's true. That's true. Because let's say you have 99% chance of something happening. The complement is 1 minus 99%, so that'll be 1%. So, yeah. Okay, number 20. Identify the sample space. Okay, that's a good question. Of the probability experiment and determine the number of outcomes in the sample space. Draw a tree diagram. Okay. Determining athlete sport. You have baseball, soccer, football. That's 1, 2, 3. And skill level, low, medium, high. Sample space is all different, right? So you should have 9, 3. It's a 3 by 3, right? For baseball, you could have baseball and low, medium, or high. So it should be L, BM, and BH. And same for soccer. SL, SM, SH. Football, FL, FM, FH. And that should be it. I don't know why there's an extra SL. Because there's only 3 sports. So it looks like this one down here. 1, 2, 3. Yeah, looks like that one. Okay, there are 9 outcomes in the sample space total. And here's the tree diagram should have BSF and low, medium, high for all 3. So it looks like A is the right answer. Okay, that was easy. Okay, 30. Assuming no questions are left unanswered, how many ways can a 9 question true or false question be answered? Okay, so true false means 2 possibilities. There's 9 questions. So each has 2 possibilities 9 times. So it's basically 2 times 2 times 2, 9 times. But I don't want to write that out. Shorthand is just 2 to the 9th power, which is 512. Okay. That's a fundamental accounting principle question. Yeah. Okay, number 40. Classify the problem statement. Example, classical probability, empirical or subjective. Explain reasoning. Analyst feels a certain stock's probability of decreasing or next week is 0.65. That sounds like subjective. Just there's a because there's no evidence based on intuition. Yep. Okay. Yeah, they didn't give any reason for that estimate. That's kind of a lame question. Let's try another one. Let's look at what's right before it. Because I don't like those subjective probability. I think that's kind of silly to even mention almost. Classify the following statement as an example of classical probability of choosing 6 numbers from 1 to 55 that match the 6 numbers drawn by a certain lottery is 1 out of 28,989. Okay, this is just a calculated probability. That would be classical. You're not gathering evidence. And yeah, every number has constant chance, equal chance of being drawn. All right, on to number 50. Probability experiment consisting of 4-sided die, spinning a spinner, showing right spinners equally likely to land in each color. Use a tree diagram to find probability of each given event, then tell whether event can be considered unusual. Event rolling a number less than 4 and spinner landing on red. Okay, so 4-sided die. Four-sided die. So that means the probability the first event happens rolling a number less than 4. There's 3 numbers less than 4. 1, 2, 3 out of 4 because it's a 4-sided die. Which, how do you construct a 4-sided die? Anyway, they somehow managed that. Okay, so 3/4, right? And then now you want the probability of then after you have the the die roll, landing on red, and landing on red has a 1 in 4 possibility. So you just multiply the two together to get your 0.1875 probability. Okay, and that was not correct. Oh, what did I do wrong here? Okay, let me reread this. What am I reading wrong? Oh, round to the nearest 3 decimal places. Oh, was that all it was? Okay, but actually, I used a tool that we haven't technically learned yet. So what's the possibility? I should write this out real quick. Let me write all the possibilities. Okay. So first possibility, you could roll a 1 and then a yellow, let's say, and then 1 and a red, 1 and a green, 1 and a blue. So this would be like one layer of the branches, and then you have the same thing for the twos, right? 2Y, 2R, 2G, 2B. Oh, I missed one. R, Y, R. No, that's right. That's right. Just space these out a little bit. Okay, and then you have the same thing for 3, right? 3Y, 3 R, 3G, 3B. And same thing for the fours. 4Ys, 4R, 4G, 4B. So this would be like the branches of your tree diagram, right? And you're looking for which one of these were you rolling a 1 and 1, 2, or 3, and then red. So that's 1, 2, 3 possibilities. So you got 3 possibilities out of the total of 4 times 4 out of 16, right? So that's another way to calculate that same thing. Okay, the tool I used the first time is actually something you're learning in a future section. So let's not use that. Let's make the full list and look where it came from. Okay, is that unusual? No, because it's not that close to 1. I mean, not that close to 0, I mean. Not that unusual. Unusual would be like 5% or less, right? All right, guys, let's do 2 more questions. Okay, when 2 purple flowers RB are crossed, RB? What do you mean RB? There are 4 equally like possible outcomes for genetic makeup of offspring: red, red, purple. Oh, RB is purple. Oh, okay, I don't know how they get RB being purple. Purple and blue. 4 equally likely outcomes for the red, purple, RB. Oh, I see. Oh, RB because blue and red. Oh, right. Okay, duh. Okay, blue is blue, BB. If 2 purple snapdragons are crossed, what is the probability that the offspring will be purple, red, and blue? If 2 purple, okay, I see. 2 purple side, okay. So for this one, first we want to see the outcomes. Outcomes, they're equally likely. Red, red, which is red. Red, blue, which is purple. Blue, red, which is also purple, and blue, blue. And those are equally likely, it says. What's the probability offspring will be purple? Okay, so looking at 4 outcomes, 2 of the 4 are purple. And so the probability is 2 out of 4, which is just 0.5. Okay, what's the probability is red? Okay, there's only 1 outcome where it's red, which is 0.25. And same for blue. It's only 1 outcome out of 4 that's blue. So again, 0.25. Okay, guys, we made it to the last question here that we're going to do. And this is an odds question. Okay, chance of winning are often written in terms of odds. Wait, did we talk about odds? I always forget because I definitely talk about odds in my Math 100 class. I forget who I'm teaching it sometimes, but let's just do it. Let's just do it just in case. Chance of winning are often written in terms of odds. I don't think we talked about odds, but let's just write anyways. Probability, the odds of winning is ratio of numbers of successful outcomes to the number unsuccessful. Odds of losing is ratio unsuccessful to successful. Okay, so for example, blah 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 blah. Okay. Actually, no, I need to read this. The number of successful outcomes is 2, and the number of successful outcomes 3. Odds of reading are 2 to 3. A card is picked at random from a deck. This is the actual question. A card is picked at random from a standard deck of 52 cards. Find the odds that it is an 8 of spades. Okay, so whenever you do these odds questions, I like to break it into 3 letters: the successes, where something happens; failures, where it does not happen; and then the total outcomes possible. So total is easy, 52 cards, right? Success is also easy because in 8 of spades, there's only 1 card. So failures is 51. So the odds are always the successes to failures, or if it's odds against, it's the opposite way. Odds that it is an 8 of spades is 1 to 51. And that's okay. That's done already. Okay, but I don't think we did odds anyways. We didn't touch on any other counting questions. I wanted to do a little more counting questions. We had one fundamental counting principle question. I think that was it. Let's do one more counting question. Or am I thinking? I'm thinking of the head, actually. I think we haven't gotten there yet, maybe. Let's see if one pops up somewhere. Oh, yeah, here we go. Here's another counting question, but we did one like that already, similar. I think I'm thinking of a future section. So let's just leave it at that. All right, guys. See ya next time. Bye-bye.